Very good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to impart tech keys. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGeek has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is on secure coding in Java, giving insights into improving security in your web applications. Our guest speaker today is Mr. Satyarth Gaur, Senior Java Consultant at Dell Pirot Systems. Satyarth has strong experience in design, development and implementation of Java and J2EE applications. He had worked in challenging projects for big MNCs as well as startups in India and United States. His works include Aadhaar, which is one of the most prestigious projects of India, giving unique identity to its citizens. Satyarth graduated in computers from NIT Rourkela and did his MBA from Institute of Technology and Management, Bangalore. Satyarth is an avid speaker in public forums on Java and is planning to launch Dr. Java Clinic to help Java community with seminars on complex Java and J2EE subjects. Gentlemen, this presentation will continue for the next 45 minutes and we'll take your questions after this presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Satyarth.
Just let me share my screen. Okay. So, welcome to this Java security workshop. I hope everybody can see your screens.
Yes, Satyarth, we can see your screen.
Okay. So, in the current webinar, we will cover the following areas, first, writing a secure Java code. We all know how to write a good Java code with optimized Java code, but here we will study how to write a secure Java code and thus overall improve the security of our Java J2EE web applications. So in security world, there is a lot of topics like application security, database security, network security, operating system security and so on, and hardware security. So today we will concentrate on application security, which is the most important topic in the field of security. So in the current slide, you see some facts and figures. So we see from the industry data collected recently in the last 10 years that most of the security flaws, all the vulnerabilities in our web applications, this applies to both Java J2EE applications and .NET applications overall. Any web applications, most of the security flaws are due to application and operating system level. If you see, it is like 41%, 36% and 15%. If you see these three cubes, which make it 92%. Other security threats are due to hardware and network related. So most of the security flaws in any web application is due to application level security and not because of hardware related security or network related security. So today we will concentrate only on application security. So we see that whenever we start any web application, today we will talk about only Java J2EE. So during the start of any J2EE application, we first understand the client requirements. But at the same time, it's very important nowadays to define the security requirements. Because see, if any project, even if it is optimized and performing well, but it is not secure, so that web project or that online system may fail because hacking is now a serious threat nowadays. And if you see the cybercrime cells in India and abroad, they report so many millions and billions of dollars are lost because of the hacking threats. So it's not only important to have a web application which is performing well, which is optimized and tuned well, but it is very important that it should be free from hacking attacks and it should be very strong enough to resist the hacking attacks. So security is a very serious threat in today's world, and so it is given as much importance as to coding. So just understanding the client requirements and use cases is not enough. We should also understand the security requirements and get the risks, what all risks are associated. I mean the security risks or the threats which are associated with any web application, and how to combat or tackle those attacks or threats. So we should have a proper security plan, and we should do a proper security testing or risk-based testing as it is called, and also penetration testing. Lot of tools in open source community is available nowadays to do penetration testing and security testing. So it's very important to make our code strong and secure enough, especially when it is an online web application developed in Java J2EE platform. So one of the rule is, whenever you design a Java application, you have to take care of certain rules so that the application is well secured and free from the hacking attacks. See, we cannot make a Java J2EE application totally free from hacking attacks. But yeah, we can minimize the risk of hacking. We can improve the security and performance by following certain thumb rules. First rule is limit access to your classes, methods, and variables. Every class, method, and variable that is not private. Yeah, every class, method, and variable that is not private provides a potential entry point for an hacker. Because if it is a public variable or a public method, anybody from the outside world can access it. So it is a good practice that everything should be private by default. And something, if it is really important to be public or protected, then you can make it so. But by default, always try to make a thing as private. So you can make all the variables as private, and you can also make all static variables as private. So if you want to allow the outside world to access your variables or static variables in the class, provide getter and setter methods. Never allow direct access to a variable or a static variable. Always provide the access through setter and getter methods. This way your code is very secure. Rule 2. Make everything final unless there is a good reason not to make it final. See, if a Java class or a method in Java class is not final, any attacker could try to extend the class, means subclass it in a dangerous and unforeseen way. Suppose I have written a class, it does some important and sensitive operations. Now I am a hacker, I can make another class and extend your subclass and then call the methods and do overriding and change the logic of the method and do some malicious operations. So by default everything should be final, as you know, because final classes cannot be subclassed and final methods cannot be overridden by a hacker. So make something non-final only if there is a good reason. So you should always understand the client requirements and the security requirements, and then decide whether to make a classes as, or a particular method as final or not. Rule 3. Don't always depend on the package scope. See, classes, methods, and variables that are not explicitly labeled as public, private, or protected are accessible within the same package. So don't rely on this only for the security, because most of the time we think that, okay, by default it is a package scope for a class, so only classes within the same package can use my class. So it's not always secure, because see, a hacker can always copy his malicious class in your package and then try to use your main class and do some malicious operations. So don't always depend on the scope of the class, but okay, I've defined the scope as package and so it is always secure. Rule 4. Don't use inner classes in general. See, some Java language books say that inner classes can only be accessed by the outside classes that contains the inner class. But this is not true, remember. Java bytecode has no concept of inner classes in reality. Actually, the inner classes are translated by the compiler into ordinary classes that happen to be accessible to any code in the same package. So suppose you have written a main class, and inside the main class you have written an inner class which does some sensitive operation. So during the translation and the compilation time, the inner class is converted to an ordinary class, Now you remember your inner classes contained some sensitive operations. Now since it is now an ordinary class after compilation, so anybody can access it and misuse the sensitive operations. So try to avoid using inner classes. Better have separate Java classes for everything. Rule 5. Make your Java classes unclonable. So it's very important to suppress or disable the cloning feature in Java, because most of the time hackers, what they do, they try to clone your Java objects and misuse them. So to avoid the cloning, as you see in the code, I have written public final void clone throws Java lang clone not supported exception. So if you add this line throws java.lang.clone not supported exception, and inside that I've written throw new Java clone not supported exception. So in this way, in any of your Java class, if you add this clone method, then nobody will be able to clone your objects of your class. And in this way, your class will become more secure. Rule 6. Make your classes unserializable. See, serialization is dangerous because see what happens in serialization, you convert your object into a stream of characters which you want to persist on a file, write to a file, transfer over a network, store in some database. So what hackers can do, the state of your object they can change. Suppose you are serializing an object and transferring over the network. In between, and a hacker can do man in the middle attack, which says that he can try to connect to your application and try to, in between the transfer, he can try to modify the state of your object and store some virus or something like that. So to avoid this, you can make your classes unserializable. And the way is to declare the right object. See, you need not worry about the read operation, but main is the write operation. Because suppose you are writing to a file or storing it somewhere. So if you override the write object method in your Java classes, in the way it is written, like I've written throw new Java IO exception. So whenever somebody tries to serialize the object, it throws an exception. And also I've declared the method as final. So a subclass cannot override it. So in this way, your classes, hacker will never be able to serialize your object. And in this way, the state of your object will be preserved and the security of the data will be maintained. But suppose you are not transferring or storing some important or secure data, then you need not worry about serialization. You can always enable the serialization. So it depends on the need. Similarly, the rule 7 says make your classes undeserializable. Just like you disabled the serialization of a class, you also disable the deserialization of a class. So it is important because the sequence of bytes that happens to serialize, a hacker can know the state of the deserialized object and he can change it. So to prevent such type of attack, you also make it impossible to deserialize your object by overriding the read object method. So you remember that in serialization you override write object, and in deserialization you override read object to disable those properties. So in this way the hacker will never be able to know the state of your object when it is being transferred over the network. He can never serialize or deserialize the object. He can never change the properties of the object. He can never manipulate them. Rule 8 says don't compare the classes by name. See, sometimes you want to compare the two Java classes, the classes of the two objects, to see whether they are of the same name. That is, whether there are two objects, now whether they belong to the same class or not. So you don't compare, suppose A and B are two objects. Sometimes you write like this: if A.get class double equals to B.get class, then A and B are objects of the same class. So this is not always useful because there can be multiple classes with the same name in JVM. So a better way is to compare the two objects directly and not by their class name. Rule 9. Ensure that the application configuration is secure. See, we all know that in a Java J2EE application, we have lot of application property files, resource bundles, XML files, Spring application XML files, struts XML files, and so on, which contains our application specific properties and important data and key value pairs. So it is very important that those files, XML files and property files, are either you try to encrypt the data or you try to store them in such a way that they cannot be hacked. So it is very important to, and one more thing is that suppose there is a very sensitive information, suppose there is a credit card information. You should avoid storing such sensitive information directly in a property file or in XML file. Rather, try to first encrypt the information and then store it, and at the time of retrieving it from the property file or XML file, then decrypt the information. So use encryption and decryption algorithms of Java. You can use Java cryptography API. There are many algorithms involving encryption and decryption. Direct classes are there. So it's very important not to directly store your important data in a XML or a property file. Rather, encrypt them and then store it. And at the time of retrieving, you decrypt first and use it. Rule 10 says sanitize the input. See, there is a concept of whitelisting and blacklisting in Java. So suppose in case of whitelisting, you expect an integer value. Then if there are any non-digit characters, you try to strip them. So you see in the following example, after whitelisting, the data will be converted into a numeric. All non-numeric characters will be removed. Similarly, sanitize with blacklist. It means that suppose you want to retain certain characters and you want to eliminate certain characters. Then accordingly, you can use the replace all command. Suppose whenever you find a special character like ampersand, replace it by null. So using replace all in the string. So in this way, when you sanitize the input, then you don't get you remove the junk character and you only get the correct input. Because see what happens, the hacker can manipulate your input from the web page, from the JSP page. He can manipulate your input, and maybe a hacker can send some malicious input. So you always try to sanitize the input and then use it in your action classes or service classes for further processing. So data sanitization is very important. Dealing with the session. See, whenever you try to use a session, first invalidate the existing web session, because what happens, the hacker can misuse the session and he can replace some important information in the session. So you always invalidate the session so that there is no garbage or dummy data in the session, and you create a new session using request.getSessionTrue, and then you set your user attributes like user ID, passwords, or any information. Similarly, in any web application, when you click on the logout button, always again invalidate or make your session as null by calling session.invalidate method. So it's very important, because what happens that if you are using not invalidating the session, the hacker can tamper your session data and he can put his malicious data, which may spoil your performance or the working of your application. And one more important tip I would like to give: never store very important information or sensitive information directly into the HTTP session. If you still want to use a HTTP session, better encrypt your data and then store it in the session. And when you when you get the data from the session, try to decrypt it and then use it. Proper garbage collection. Rule 12. We always know that the garbage collection is automatic in Java. So, but we always use the good practices that we always you make our objects and fields as null in the finally block, so that those objects become eligible for garbage collection. And then we call system.gc or runtime.gc, because our ultimate aim is to clean the JVM heap. Remember that heap contains your class level instances and objects. So if you are not garbage collecting your heap, a hacker can hack your heap, get the important information from the heap and misuse it. So it's very important to clean your memory. Suppose you are creating a database connection. So always initialize the connection object to null in the finally block. Once the operations are completed, then make it null and then make it eligible for garbage collection. Rule 13, proper validation of data. It's very important to validate your data both at the client side and server side so that your web application is free from the hacking attacks. Always try to validate length, range, format, data type in the client side using JavaScript, jQuery or any other technology. You can also use struts or Spring client side validation. Reject the invalid input rather than trying to sanitize it. If you find an input which contains any special character or any malicious character, just reject it rather than trying to sanitize it, because that special character may be a virus. Just simply reject that input and log out. Make the user log out. You can use regular expressions, validations to constrain the text input. Like you can use regular expression to see that if email is in a special format or specific format or not. So suppose you get an email in a different format, you can always know that it is from an unauthorized user or a hacker. Do not forget the error messages. They too might contain the invalid data. So always check the error messages and see whenever you log any error messages or display any error messages, don't show any sensitive data or important data because it can be misused. Only show the specific or relevant error message. Now I am giving an example. Suppose there is a password. So if a password matches the regular expression which says that it is an alphanumeric A to Z or 0 to 9. Now if the password contains any other character, I can reject it. As you see in the next example, my password is containing some special characters like colon, equal, bracket. Then I can see, okay, this is some suspicious password or somebody is trying to break my authentication. You can always use struts validators to validate all input at the client side, because see, struts validation has lot of inbuilt routines which you can directly use. Suppose you have a field which is mandatory, so you can use the field property equal to name depends equal to required to check for a mandatory input. Similarly, you can see the other example where there is a credit card input which is required. Now in the next example you see there is a field called password. So whenever you encounter any special characters, you can always also replace it by null. This is again same as sanitization. So suppose my password contains some character like colon, equal, bracket or slash, which is not allowed in my web application. I can always replace it by null and then use it further for logging. But it's always better to reject such users, because see, if there are any authorized users, they will never accept such password. So just not allow them to log in if your input password contains any suspicious character. Rule 14, detecting the code flaws in your web application. See, whenever you write any Java J2EE application, do not always rely just on manual or automated code review. Do both manual as well as automated code review. Automated code review you can do by configuring tools like PMD, which is Programming Mistake Detector, and Find Bugs in your IDE. You can use Eclipse or NetBeans. You can configure these two tools and then start your coding. After you have done your coding, do a strong unit. Yeah,
Satyarth, can you repeat rule number 13 once again?
Okay.
Right. Thanks.
See, rule number 13 says you have to properly validate your client side or input data. So whenever there is any unwanted input, you can always reject it. Or the second way is, if you don't want to reject it, you can always sanitize it by replacing the unwanted character by null. But always check your input and then use it for further processing. Don't directly accept the input and just send it to the action classes or your service layer. So in rule 14, I was telling you, you can always configure tools like PMD, programming mistake detector, and find bugs in your Eclipse or NetBeans, and then start your Java code development. After you have done a Java code development, do a proper peer-to-peer manual code review. See all the layers of a Java application, whether it is a UI layer, whether it is a service layer, whether it is a DAO layer, to see if there is any bad practice or there is any anti-pattern or there is any flaw in the code, or you can optimize the code, you can improve the security. Do a strong penetration and unit testing. See, penetration testing is something like you try to become a hacker and try to break your own code, try to bypass the login authentication, try to break the security, try to tamper, say, your hidden variables, try to tamper the session, try to hack the cookie or something like that. You can do those type of steps to see how secure or how strong is your code. Rule 15 says using dynamic SQL. See, sometimes what we do, we get the username and password. If you see in the current example, I'm trying to get the username and password from the request. The user and password is set, say, as a variable in the request parameter in the JSP. And from the JSP, I directly get the username and password, and I'm trying to use that in the SQL query. So here, what happens, since you are getting the username and password directly from the JSP parameters or from the UI, the hacker can tamper and try to send some malicious password. See, in the current script, I have written the value of the password as or 1 equal to 1. So such type of scripts are malicious scripts where the behavior of the script is different. Actually, this password will be converted into a, say, a delete query or something, and it will try to delete the data. This is called SQL injection. So to avoid this SQL injection, don't try to directly use the username and password from the request, which is from the JSP parameter. Instead, try to use the prepared statement and set the username and password in the SQL query directly by using the setters. See, in the current example, I've used the prepared statement, and I'm setting the username and password by setter, set string method. I'm not getting the username and password from the request object from the JSP. So in this way, the hacker will never be able to send some malicious password, because the password you are setting it inside your DAO class or inside your service class using the setter method. So this prevents the SQL injection. Now there are some more tips for, I will say, the overall tips for Java J2E application security, which I have encountered in my previous experiences while working in the UID Aadhaar project. So try to use IP addresses rather than using host name or DNS name, because this improves better security. Grant read or write permissions for database to users very carefully. So only those users who are authorized or who have the access controls, only grant them the read or write permissions. Also, on each of your application files, even if it is an XML file or a property file, have proper file permissions. Because you will never want your XML file or property files which contain important information to be hacked by the hacker. Always set a password for the root or the admin account, and never keep the password as empty. Sometimes we make the mistake as keeping the username as root and password as empty. Never have the empty password, because it can be manipulated by the hacker. Always set some password and change it from time to time. Never hardcode the username and password directly in a Java program or in a .property file. Better way is to store the username and password in some database table in an encoded format and try to hit the DB database, get the username and password and decode it and use it in your application. Always use some hashing algorithm to generate a unique password corresponding to a user ID or a login ID. So use a strong hashing algorithm to generate a unique password. A password should be very strong enough. It should contain a set of alphanumeric, numeric, special characters, and it should not be easy to replicate or copy. So you should use some strong random algorithm or a hashing algorithm to generate a password. Use prepared statement rather than a normal SQL statement in Java to protect against SQL injections, which I have already discussed earlier. Avoid directly hard coding the sensitive information in the SQL query. So don't try to hard code the sensitive information, which can be a password or some credit card number, in the SQL query. Rather use the question mark, as we have discussed earlier, and use the setter method to store or inject that value, the input value. Always enable the secure socket layer in the database server. Whether you are using Oracle server or MySQL server or any other server, always try to enable the SSL feature, which is present in every database server. In any web application, it's better idea to disable the back button in the browser. Always try to log out after more than 3 unsuccessful login attempts. Because see, if there are more than 3 unsuccessful login attempts, maybe there is some malicious user or a hacker who is trying to break your application by sending some different passwords. So it's better way to log out after 3 unsuccessful attempts, or better lock the password or lock the user ID. Use post instead of get in the JSP. Remember, never use get URLs to process the sensitive data. So whenever you are dealing with some important transaction or some sensitive data, never use get, because everything will be appended in your URL, and your URL can always be hijacked by a hacker. So it's better to use post method in the JSP so that your entire information is encrypted. Perform the URL detection. Report an alert if a number of hits in a time period from a given IP address exceeds the specified limit. This is known as application hijacking. See, suppose I am a hacker. So what a hacker does, like he writes some program which has a loop of say 1000, and it continuously tries to hit your application or hit the URL, so that your application server may be down or it crashes. So this way he is able to hack your application or crash your application or slow down the performance by sending repeated requests simultaneously. So try to always see from which IP address you are getting a request, and if it is an unauthorized IP address, don't respond to that request. Always perform client-side validations of input data to catch the malicious input before it reaches your server or application. Because see, if you are not having a strong client-side validation, and once the input reaches your server or server side, then it is too late, because it can be a virus also. So always perform your client-side validation in the JavaScript or jQuery, and try to remove any unwanted input, or try to reject if there is any suspicious input. Just try to stop there. Log out. Never store sensitive information in JSP hidden fields. It is a bad idea to use a lot of hidden variables in the JSP, because see, if I do view source in my JSP application, I can see the hidden variables. I can tamper it as a hacker. So try to use minimum hidden variables unless it is needed. Try to update your login passwords periodically from time to time. Now, the next tip is SOAP XML messages should be preferred for communication. So rather than sending a message as a string or in any other format, say as a byte stream, it's better to send it as a SOAP, embedded in a SOAP envelope, because it is more secured. Never keep any important information in error log or console error messages, because what happens as a hacker, I can access your log file, and if there is any important information in error messages or in the log file, I can misuse it. So only log specific error messages, which is to the point and relevant. Try to catch all the relevant and specific exceptions. Don't ignore any exception. Always try to catch all possible exceptions. Pre-initialize the variables to their default values always. Because see, if you don't initialize a variable or an object, then what happens sometimes it is initialized to some default value or some garbage value or undefined value, which may spoil the performance of your application. So it's always a good idea to initialize your variables and objects as null or to their default values. Data should be private and static whenever possible. See, again, we have discussed in the earlier slides, whenever data is private, then outside world cannot access it and cannot tamper it. During file uploading, the uploaded directory should not have execute permissions. See, in many applications, we always have a browse button where we have a file upload feature. So the uploaded directory should never have the execute permissions, because what happens, the hacker can upload the file and he can execute some of the things. So disable the execute permission in the file. Perform garbage collection using finalize method. See, you can always override the protected void finalize method and call system.gc there to invoke the garbage collection. Though it is not in your hands to start the garbage collection because it is automatic in Java, but yeah, as a good programming practice, you can try to perform garbage collection by overriding the finalize method. This way you are clearing the JVM heap, and thus all the unwanted or unused references are reclaimed by the JVM. So they cannot be misused by the hacker, those memory locations which are no longer being used. Because what happens, suppose I'm using a memory location and now it is no longer being used, but it is also not garbage collected, then hacker can store some malicious data in that memory location. Always validate input XML documents before processing them. So it is important that any input, whether it is in XML format or a string format, you are validating it against XSD and checking whether it is a proper well-formed input XML. All its values are correct in all the nodes, and then only use it for further processing. Before reading any file, check for the file name, file type or extension, file size. Because what happens, it can be a virus file also. So check whether the read permissions are there, because there are chances that the file might be malicious. So don't accept a file directly from the user. Check for overflow or out of memory issue during any file or array copy operations in your code. So sometimes what happens, like you can receive because see, your application deals with lot of files over the network. One of them can be a very big file which a hacker has given just to slow down your application. So check for the size of the file and check for the overflow or out of memory issues. Calculate checksum during the message or data transmission for error. See, checksum is an algorithm where you append certain bits at the input side, at the client side, and check it at the server side. What happens if the hacker has tampered your data? Then the checksum will not match, and you will always come to know at the server side that your data has been tampered. So you can also use some hashing algorithm or append some random number or some algorithm you can use at the client side, so that you can always verify the data at the server side is the same and there has not been any tampering. Avoid passing a session ID in the browser URL, because the session ID can be duplicated and a hacker can replace it by a malicious session ID, or session hijacking can be basically done. So don't pass session ID in the browser URL because it can be cloned by a hacker, and he can duplicate your session and he can start his own session. Destroy or invalidate the session variable and override the cookies whenever user log out. Always set a session timeout, say some 20 minutes or some timeout on the HTTP session. Do not have a timeout of say, 24 days or 60 days, because see what happens, your session can become stale and it can be hijacked by a hacker. And try to avoid the browser caching. It's always a good idea to disable the caching in the browser, be it an Explorer or a Firefox. Disable the browser caching because see, browser cache can store some of the important information like user ID and password. And suppose I am a hacker and I get access to your system or your personal computer, then I can hack your cache also and get some important information like username and password. Always parse the SQL statement or the SQL query before execution. Because see, in the SQL query, there might be some malicious input parameters. So always check for some special characters like there is some quote and replace it by slash. Because what happens like whenever you have a SQL query, you are generating it. It depends on certain parameters. Like suppose you have a SQL query, select star from user table where username equal to something and password equal to something. So if you are not checking your SQL query, you can blindly execute it and then it may delete some data because there might be SQL injection. So always check your SQL statement, check all the input parameters in the SQL statement and then only execute it. So basically I've come to an end and I'll also share some more things, some more tips and tricks to make your application code more secure. As I've told, like you can use tools like PMD and find bugs, and there are many more tools which check if there are any bad practices in your program and how you can overcome the bad practices. There are many open source tools which you can download. Can I have the questions now? Or if there is any slide or any point which I can
We have already shared.
once again.
We have already shared the questions with you.
Okay, I'll just see the chat panel.
You would have got in the questions panel.
Okay, basically I cannot. Okay, let me see.
There's a questions panel.
Yeah, I have. Okay, I got it.
Right, you can undock the pane by clicking on the button just before the close button.
Okay, yeah, I got it.
You can make it big.
I'm trying to see the questions. Yeah.
Right.
Yeah, there are a lot of questions. I'll try to answer some of the important ones, the most relevant ones. See, one thing I would like to tell to all the audience, like for the website security, it's very important to do a penetration testing. You can use HTTP unit, just like you have a JUnit in Java to do the unit testing. You can use HTTP unit to do the website testing and see how strong your authentication and authorization mechanism is. See, some of the questions again discuss about how to improve the Java security. See, one of the tip is that just like you have a singleton class. So what happens singleton classes, why are they secure? Because the constructor is private, so it is not accessible to the outside world. So whenever you want some of your code should not be accessed by the outside world, you can always make the constructor as private, you can make the code as private, and you can remove the getter method. See, if there is no getter method, the hacker or the outside world can never access your variables or the code. So you can only provide the setter method, so and so on. PMD. See, PMD is a tool, basically the programming mistake detector. It detects, see, in the Sun Java coding guidelines, there are some of the best practices, and some of the programming practices are there which every Java developer must use while developing any code. So if any of the best practice is missing, I think my screen is okay, yeah. So programming mistake detector basically like detects the basic best practices which are missing in your code, or if you are not writing the code as per the Sun Java coding guidelines or the basic programming practices, so it detects the mistakes. Suppose you have declared a variable and you are not using it, or suppose you have declared a variable but you have not initialized it to a proper default value. So those type of things PMD will find out and in your code and warn you. Same is for find bugs. These two are very widely used tools to point out the basic deficiencies in your code. See, because security loopholes are always arising because of any deficiency in the code. If your code has no deficiency, if it is as per the Java coding guidelines, if it is having all the best practices, then automatically your code becomes more secure. See, SQL injection. See, what happens in SQL injection, there are some special scripts. Suppose you have a username and password as text field. So what happens, I am a hacker, I can put some script in the password text box. So that script is basically the value of the password, but it is a script which is a malicious script. And the behavior will be different. It might delete some data in your database or do some malicious operations. So to avoid those type of scripts, you always check what is at your client side. You always validate your password or validate your input. If it contains any special character or any such scripts, you can always eliminate them. See, one of the audience has asked about the IP address, like how to check if it is a malicious IP address. See, you can suppose I am a host, I am a server, and many people are connecting to me. So there are always APIs in Java, like I can always get what all people have connected to me, what all client IP addresses I can get. So I can check for each IP addresses, I can check how many requests it is sending in a given time. So suppose in a minute, from one IP address, in 1 minute I am getting 10,000 requests. So I can always doubt it, and I can block that IP address from my list. I will always maintain a list of the IP addresses which can connect to me, which can connect to my application. In the IP address, like if you go to Internet Explorer tools, properties, advanced properties, you can always disable some of the URLs or disable some of the IP addresses. So this way you can prevent the denial of service attack. One of the questions discusses about the hidden fields. It is very important never to store your important or sensitive information in a hidden variable, JSP hidden variable, and also never store it in a session, HTTP session. Even if you want to do that, better encrypt your information and then store it, so that at the time of retrieving, you decrypt the information and then use it. And the worst mistake which we make, that storing the important information in a property file or a XML file directly. Better store it in a database table, important information or sensitive information, and try to retrieve it from database. Because see, it is always difficult to hack a database than hacking an application. See, blacklisting and whitelisting is basically removing the unwanted input from the input data. That is sanitizing it. Suppose there is any special character and you don't want it, you can always eliminate it and replace it by null or truncate it. Is there any other questions like, because most of the questions like I have answered.
In slide number 2, rule number 2 once again, please.
Okay. See, it is a good practice to make a class as final, to make a method as final. Because see, final methods cannot be overridden and final class cannot be subclassed. Suppose if I have a class and it contains some important information, it is doing some important business logic, and the class is not a final class, and the methods in it are not final also. So I am a hacker. I can write a class and I can extend that class with your class. That is, I can subclass your class. So in this way, I can override your method and I can misuse it. So in order to avoid your classes from being subclassed by a hacker, try to make it final class.
I have forwarded some more questions to you.
Yeah, I'm seeing the questions window. I'm seeing it. Yeah, see, how does soap help? See, it's very well known that soap contains a header and a body. What happens if I'm sending an information, I can convert it into an XML information. Suppose I have a information which is a string or a file stream or a binary stream. I can convert it into an XML. I can store that in XML as a SOAP envelope. So what happens in a SOAP envelope? I have a header. I can put some identifier or put some checksum in the header, so that at the receiver end I can always check the header and check the checksum, which can be some random variable or some extra attribute which a hacker does not know. So in this way, and also in the SOAP XML, I can use XML security also. There are tools which can encrypt the entire XML, entire SOAP XML. So rather than directly transmitting the information as a file stream or a binary stream, better transmit it as a SOAP envelope containing the XML data. Because it's difficult to hack the SOAP data, to break the SOAP envelope. It is more secured. How to prevent the memory leakage issues? This is a very important question because it is very related to security. See, it is difficult to prevent memory leak in Java, but what you can do, you can optimize your Java code. Suppose you use some variables. Before using it, you can always initialize it to some default value. Suppose you are using a hash map object or a linked list. You can always initialize it to some dummy values or some null value and then use it. And once you have used the program and your program exits, before the end, you can always make it null in the finally block so that it becomes eligible for garbage collection. Because see, if you don't make a variable or object as null in the finally block, it will never be reclaimed for garbage collection, and it will be lying dormant, and it will eat up your memory. Because see, I'm using a hash map. Now my purpose is over. I've done all the work. Now I'm not making the hash map object as null in the finally block. So it will always be remaining in the JVM memory idle and eat up the memory. So it's very important to prevent the memory leakage by optimizing the variables and the objects and making it as null in the finally block. See, which is the best way to secure the authorization of a JSP page? See, there are a lot of like mechanisms where you can authorize, do the login authorization and authentication. You can use LDAP, you can use VESP, so and or you can just use a simple action classes, a login class or a login interceptor to authenticate your username and password. Suppose I enter username and password from the JSP page, and you have a list of valid username and passwords in the database. You try to hit the database, get the list of all the users and their passwords in the form of a linked list or a hash map. Now try to compare your username and password. If it matches, then you allow the user to log in. So there are a lot of mechanisms, but it is very important to properly check the data in the login and the password and then try to match it. If your password contains some malicious character, it is waste of time to hit the database, get the list of passwords and compare it, or better reject it at that time. So first check your input, and if it is a proper input, then try to authorize or authenticate it. But don't do it in the JSP. Try to do it in the action classes, the login authorization and authentication. Don't try to avoid using scriptlet in JSP. See, one of the tools I have used for security threat, it is called Paros. Paros is a tool where you can bisect your entire request, which is HTTP request, and you can see what all is coming in the request, what all is there in the hidden variables, and all that thing, session ID. So Paros is one of the tools. And there are many other tools where you can do your web application security testing. I'm seeing some more questions.
Satyat, we have received many questions related to this, like why use IP instead of DNS or a host name?
See, because from IP addresses is always unique. Because see, for every machine we have a unique IP address, we can generate it, and for every IP address you can associate a URL or a session ID. But see, host names, like you can have a dummy host names, and it's difficult to resolve the host name because, but it's easier to identify using IP address. Like I am a server and many people are trying to connect to me. So by IP address, like I can identify, okay, for this, because IP address is unique to everyone. We cannot have two duplicate IP addresses for different machines. So over the network, like it is easy to identify who all is connecting to me by IP addresses rather than a host name or a DNS name. The resolution or identification is easier if you use IP address.
How can I override cookie with my HTTP session?
So basically we can say IP address is more reliable during authentication. Yeah, what you asking?
How can I override cookie with my HTTP session?
Yeah. See, basically, like in the Java, like we have a cookie class. Normally, it is a good practice to disable the browser cookies. So, because see what happens. Uh, so first time when you log in, you are authenticated and authorized. The next time, your information is already stored in a cookie or a browser cache, and the application tried to refer to the cache rather than referring to the database again. But sometimes what happens, a hacker can hack your cache or cookies, and he can try to change the data in the cookie, replace your password by his password. So, so it's a good idea to disable the cookie, or in fact, like disable the browser cookie at all, and not use it unless it is needed. So there is an option in the Internet Explorer browser where we can disable the cookie. Also, there are some JavaScripts also in the ActiveX. We can write some scripts where we can programmatically disable the cookie.
The other question which many people have is how do I disable back button from of the browser while developing web pages?
See, back button can be disabled so there is a JavaScript like right now I'm not remembering the exact code, but in the JavaScript you can always check the type of the browser if it is Firefox or Explorer, and depending you can disable the back button. You can do history.go back equal to false or something, or history.go back pass at -1. So there is a JavaScript, 1 or 2 lines of JavaScript which you can write in your at the start of your code. You can have a comment.js file, and all the JSPs will load this JavaScript at the time of initialization and disable the back button when the page is loaded.
Right. Thanks, Satyat. We have almost
And
answered.
so what happens?
Please go ahead.
Yeah, hello.
Yes, Satyat, you are saying something.
Yeah, no, I'm waiting for more questions.
Right. Actually, we have overshot our time right now, and we have almost
Okay,
answered the major part of the questions which many audience has. And I'll share
right.
the rest of the questions with you where we can have them answered offline.
Okay.
Right. Right. Before closing, you would like to say something to the audience?
So what I would like to say is uh, before starting the coding in Java, it's very much advisable that you configure PMD and find bugs, because to some extent they eliminate your security flaws. And after you have designed your application, do a secure code review, a manual code review. Try to see some security loopholes in your code, because the security loophole can be in your JSP, it can be in your action class, it can be in your Spring Service class, it can be in your Hibernate DAO, it can be anywhere. So you have to identify the security flaw and replace it by a good code. So this is all I want to say.
Right. Thanks, Mr. Satyat, for your session on secure coding in Java for improving security of web applications. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. Well, the recording of this webinar will be made available on techgeek.com by tomorrow. Just an announcement for you, all the audience here. This November, TechGeek is conducting webinar series on e-commerce and business intelligence. Uh, as as part of the web commerce series, webinar series on e-commerce, and we are conducting two sessions. The session one is on the topic commerce, the changing landscape by Mr. Abhishek Kalra, practice head at HCL. This session is happening on next Tuesday, that is November 8th at 3 p.m. The second session is on the topic WebSphere Commerce Suite, a practical guide by Mr. Nikhil Ratnapati, Senior Manager Technology at Sapient. This session is happening on next Wednesday, that is November 9th at 3 p.m. So see you all next Tuesday at 3 p.m. Thank you.
Thanks a lot.